We have the following polynomial, and what we want to do now is to find all the possible rational zeros, and then find all the zeros, and then write the polynomial again in a factored form. As you can see, the degree of the polynomial is 3. So this means that we expect 3 zeros. In order to complete number 1 and find all the possible zeros, we need to use the theorem for rational zeros. What the theorem says? The theorem says that we have to focus on two numbers, the constant and the leading coefficient. We need to find for the constant all the possible factors. Since the constant is 1, the possible factors of -1 is plus or minus 1. And this is the constant, and the leading coefficient. The leading coefficient is 3. All the possible factors of 3 are going to be plus or minus 1, this is always a factor, and plus or minus 3. Now we need to consider the fractions p over q, where p is a factor of the constant and q is a factor of the leading coefficient. Okay, so we need to create all the fractions, plus or minus 1 over plus or minus 1, plus or minus 1 over plus or minus 3. Why? Because 1 and 3 are the factors of leading coefficient, and plus or minus 1 is the only factor of the constant. So this one is going to give me just two possible just two possible zeros, and this one will give me another 2 possible zeros that are these. So these are the only rational zeros, possible zeros, for my polynomial. At the second step, what I need is to find all the zeros. I consider my polynomial, that is 3x squared, plus x to the third plus x squared minus 3x minus 1. What I can see right here is that I can factor in pairs, so I can group factor. If I group factor the x squared here, inside the parentheses will remain 3x plus 1. And if I group factor the negative x here, inside the parentheses, if I group factor -1 here, there is nothing to factor mainly, except of the sign. Inside I will have 3x plus 1 again. Now I can factor from both terms, x squared times 3x plus 1 is the one term, and -1 times 3x plus 1 is the other term, the 3x plus 1, that is a common factor. I factor this out, and inside I have x squared minus 1. Okay. Now, there are many ways to continue. First of all, this is a linear factor. So if I solve it, 3x plus 1 equals to 0, this will give me that 3x is equal to -1, so x is going to be -1/3. And as you can see, this is one of the possible factors of my polynomial. At the next step, there are many ways that I can factor that. I can factor it with the square root property, I can factor it with a quadratic formula, or I can see that this is nothing else than a difference of squares. It doesn't matter how you factor it. Let's do it with a square root property. X squared minus 1 is equal to 0. This means that x squared is equal to 1. This means that x is equal to plus or minus 1. So this gives me two roots. X is equal either 1 or negative 1. Again, I can see that both numbers are possible rational zeros. So this means that I have 3 zeros for this polynomial, as I expected, since it's of degree 3. So I can rewrite the polynomial into 3x plus 1 times x minus 1, because of this 0, times x plus 1, because of this 0. This is the factored form of the polynomial.